Hello guys. First of all, sorry I couldn't be there today and tomorrow, Thursday and Friday, but I wanted to make sure that everybody had a chance to get all the information they needed for the final so that we could go in next week and you guys could ask whatever questions you needed and we would be good to go for that. So basically how this is going to work is the sub should have passed out a review to you already. And so you just need to follow along and fill out your review as we go along. Any questions that you have, you're more than welcome to email me at the email address on the screen. That's celnifon@olatheschools.org. So anything that you have, you can send me an email, and I can answer any questions like that. Also, you can post something on Edmodo if you have a question, and I can answer it that way as well. And please remember, I will be back on Monday to go over any questions before we actually take the test on whichever day your final is. One thing to remember is that anything on this review is fair game for the final, meaning that if it shows up on this test or this review, it could be on the test. If it doesn't show up on the review, though, you're probably okay with it not showing up on the test. So anyway, let's get started. So on the first page, first question is a pretty basic one, which is just what is an element? So this seems like a pretty easy question, but I do want to make sure that we have a good grasp of exactly what an element is when we're going in. So you remember that an element is the most simple form of matter. Okay, so it's the most simple form of matter, meaning that if you take something and chop it up into little tiny pieces, so we start big, and we keep cutting stuff smaller and smaller and smaller and smaller. An element is the smallest piece that still retains the physical properties of whatever that thing was when you started cutting it up. So, for example, if you take a gold bar and you cut that gold bar in half, then you cut the halves in half, and keep cutting it down and down and down. Once you get to a single atom of gold, that is the element. It's the smallest piece that still retains its physical properties. Okay? So, next question is about temperature. So, what does temperature actually measure? So, temperature is one of the newer things that we've been talking about. We've been talking about during phase changes and states of matter, physical, chemical changes, all that. So temperature is actually a measure of the amount of energy in a substance. The amount of energy. So this is also, you could equate this to molecular motion. It's a CU. I'm still a little bit of a rookie with the tablet, so bear with me. But so temperature is measuring both the amount of energy, which is really measuring the molecular motion, meaning the individual atoms or molecules within a substance are constantly moving, and how much they're moving is measured with temperature. So if they move a lot, that's a high temperature, high energy. If they're not moving very much, that's a low temperature, that's low energy. Okay? So next, we're going to stick with this trend, and we're going to talk about the four common phases of matter. So the four common phases of matter we'll put them in energy in order of low energy to high energy. So if we start low energy, our low energy of the commons is going to be solid. Okay. After solid, if we gain a little bit of energy, our next is a liquid. Okay. If a liquid gains energy, it can become a gas. And then finally, if a gas gains more energy, more heat, you finally end up with plasma. Okay? So these are our four common ones. There's that fifth one that's way down here, but we're not going to worry about that one because it's not very common. So solid, then liquid, then gas, then plasma. Now, the only difference between these phases of matter is the amount of energy in them, which kind of leads directly into the next question, because the next question is asking about energy. So, what happens when you add energy to a substance? Well, first of all, remember energy is usually being added in the form of heat. Okay, so the idea is like you're heating something up. So if you add energy in the form of heat, you're going to change phase. So what that means is transition from one to the next. Okay? So basically, as you add energy to a solid, if you add enough energy and those molecules start vibrating more and more and more, and if they vibrate enough, you're going to transfer it to a liquid, and the item will take on the properties of a liquid, which means that it's going to be flowing over each other, the molecules are moving more, they're going to start adhering to the to the shape of the container. Still a fixed volume, but it'll start flowing more easily. If you shake those molecules even more, get them vibrating even faster, they'll start breaking loose. You'll get to a gaseous state, a gas. In the gas, we're going to be able to fill the entire shape and volume of the container, fill it up all the way. And then if gas becomes superheated, you keep adding energy. Eventually that will transition into plasma. Plasma is not very common here on the surface of Earth, but just know that it is actually in the scope of the universe very, very common. It's a very high energy state of matter. So, okay, so now we're looking at the properties of matter. These are the ones that we looked at way back at the beginning of the semester, and so we just need to review these really quickly. So, first, hardness. Hardness is very simply the resistance to scratching. So what that means is it's like diamond. Diamond is very, very hard. The only thing that can actually scratch a diamond is another diamond, okay? So hardness just basically means if you scrape something across it, if it's very, very hard, it will not scratch, whereas if it's not as hard, it will scratch. So diamond would be very hard, something like a wax, like a candle, which you can scratch with your fingernail pretty easily, that would not have very good hardness. Next, brittleness. Brittleness is a measure of how easily something shatters. Okay, how easily something shatters. So if something's very brittle, when it's dropped, it will shatter. It will break into lots of little pieces. Whereas if something is not brittle, when dropped, it won't shatter. So something very brittle, a great example of that is glass. So if you have a glass in your hand and you're walking across a concrete patio and you drop it, that glass when it hits the ground, it's going to shatter. Versus if you were carrying like a metal baking pan and drop that on the patio, that's not going to shatter. It won't break into lots of little pieces. Next is elasticity, and elasticity is the ability to stretch and return to original shape. So obviously like an elastic band or a rubber band, you can stretch out, make bigger than it once was, and then when you stop stretching it, it shrinks back down to its original shape. So you can stretch it out and then return to its original shape. Malleability. Malleability is one that's maybe not as familiar to you. These other ones you kind of come across with in your everyday life. Malleability is a little more removed, but malleability is just the ability to be pounded into thin sheets. Thin sheets. Okay. So if something's malleable, if you hit it with a hammer, it'll flatten out. So lots of metals are very malleable, and that's how you can get like a very thin sheet, like aluminum foil. Aluminum is very, very malleable because it can be pounded into that thin sheet. Compared to something more like, again, glass is a great example of something that's not malleable. If you took a piece of glass and tried to hammer it into a sheet, it would not hammer into a sheet, it would just shatter. Okay, so malleability is if you can pound it into a thin sheet. Finally, viscosity. Viscosity is very simply the resistance to flow. Okay, resistance to flow. So viscosity measures how easy it is to pour something. So high viscosity means it's hard to pour. Okay, so like a thick thing like molasses or syrup, corn syrup, with very high viscosity, so they're hard to pour. They're very slow to come out of the bottle. Whereas something like water, water comes out very easily. It has a low viscosity. It flows easily. Continuing, tensile strength. Tensile strength is how strong something is to pulling forces. So what this means is if something has high tensile strength, you could pull on it, tug on it, and it won't break. So, for example, you would probably want, if you were a rock climber, and you're going to go out and kind of put your hands in the life of a couple ropes on a rigging, you would want those ropes to have very high tensile strength, because that means they could resist those pulling forces, and you wouldn't have to worry about the ropes breaking and you falling, 50 feet to your death. It would hold you up, which would be good. Finally, density. Density is very simply a measure of compactness. What that means is it's the amount of mass in a given volume. Okay, so density actually works in here to the density equation very nicely. So the density equation is actually, very simply, D equals M divided by V. Okay. Within this equation, D is obviously density. Now density, there's an I in there. Density is measured in grams per milliliter. Okay. M in this equation, M stands for mass. Mass is measured in grams. And finally, V is volume. And volume is measured in milliliters or sometimes centimeters cubed. Okay. milliliters and centimeters cubed are actually the same thing. These two things, milliliters and centimeters cubed, actually mean the same thing. It's just a different way of saying it. So if you're saying something in liquids, a lot of times we measure the volume of liquids in milliliters, and sometimes the volume of a solid, so like a cube, may be measured in centimeters cubed. But just know that 1 milliliter equals 1 centimeter cubed. Okay, they're the same thing. Anyway, so remember, in order to do any of these, we're going to have to keep the density equation in mind, which we just wrote down. But if you've forgotten to write it down, which I'm sure you haven't, but just one more time, just for old time's sake, D equals M over V, mass divided by volume. So first, this question takes a little bit of doing. Anytime you have a question like this, especially on the test, you're going to make sure you show your work. There will be credit awarded for showing work, and if you just, like this one's asking if it's going to float or sink, if you just take that 50-50 guess, you won't get full credit if you don't show how you got the answer. Because, like I've said, it's not so much the answer that matters, it's how you got to the answer that matters. It's, you want to be able to explain yourself. That's the most valuable thing. So anyway, we say the density of water is 1 gram per milliliter, which hopefully you just kind of remember. If you don't, there it is. So the question is, would a 5-gram sample with a volume of 20 milliliters float or sink? So in order to answer this question, first thing we need to think about is what kind of densities would float in water. So remember, less density means you will float. Okay, so a lower density means float. A higher density would mean sink. So if this sample's density is less than 1 gram per milliliter, it'll float. If it's more than 1 gram per milliliter, it will sink. So all we have to do is just calculate the density. So we know D equals, density equals, first our mass, our M equals 5 grams. And we know our V, our volume, equals 20 milliliters. Okay? So now we're just going to plug those into this equation right here. So D equals M, which we just said was 5, divided by V, right here. V is 20, so divided by 20. So D equals 5 divided by 20, 5 divided by 20. You do that calculation. 5 divided by 20 is the same as 1/4, or 0.25. Our unit density is measured in grams per milliliter, because it's 5 grams divided by 20 milliliters. This is with grams divided by milliliters, so 25 grams per milliliter. 0.25, excuse me. So that gives our final answer of 0.25 grams per milliliter. So 0.25, we know 0.25 is less than 1. So 0.25 grams per milliliter is less than 1 gram per milliliter, which is the density of water. So if we're less than 1 gram per milliliter, that means we are going to float. Okay. Let's check our time. Okay, doing good. Okay. So Next question, how can you measure the volume of an irregular object? So if you're trying to measure the volume of an irregular object, you're going to have to come up with a way to actually figure out how much space it's taking up. Now, normally measuring the volume of a regular object is easy. That's the kind of stuff you learn in geometry, you know, like you learn your volume equations for cubes and spheres and cylinders and all that kind of stuff. But if it's an irregular object, irregular means that it's not normally shaped. It's got some weird shape. So think of something like a toy car, or try and find the volume of, you know, a weird a marker, a pencil, or, you know, something that doesn't have a totally normal shape. It's got some weird edges to it. So if you're trying to find the volume of a irregular object, you have to use something called the displacement method. Displacement method. Okay. The displacement method basically means you measure the water displaced by the object. Yep. Measure the water that is actually displaced by the object. What that means is, this is, if you remember back to when we were talking about density calculations and volume and all that, this was the idea of using a graduated cylinder that had a certain amount of water in it. So here's our grad. It's got, you know, water in it, and let's say that water is at 20 milliliters. Okay. At that point, we add our object. So there's our object, little potato-looking thing. And now our volume has gone up, and so our new volume now is 35 milliliters. Okay, the only difference between this is we just added that object. So what has happened is that object is taking up space. It's displacing the water that used to be there. So it's not like we added any water. I did not pour any more water into the graduated cylinder. I simply added this new object. So this new object displaced the water, meaning the volume marker went up from 20 to 35. So volume of the object is going to be final volume minus initial volume. Okay, so in this case, final is 35 milliliters minus the initial, which was 20 milliliters. 35 minus 20 is going to leave you, meaning the object has a volume of 15 milliliters. That's a 5. Yeah. Okay, 15 milliliters, because that's just the difference between your final and your initial. So, going back to calculating density, we want to find the density of a cube with 4 centimeter edges and a mass of 16 grams. First of all, a cube with 4 centimeter edges is going to be a cube. 4 centimeters edges means that all of the edges are 4 centimeters. So there's our cube. And so this is 4, this is 4, and the depth is 4. So they're all 4. So we can find the density of this. Remember, density equals mass divided by volume. Okay? So in this case, mass is given to us right here. It says mass of 16 grams. So mass equals 16 grams. Volume we can find pretty easily because we have the width, the height, and the depth of this cube. So if we have all three of those volume measurements, we can find, or all three of those dimensions, we can find the volume pretty easily. The volume is going to equal those three numbers multiplied together. So volume is going to be 4 times 4 times 4. Okay, 4 times 4 times 4, because that's the width of the cube times the depth of the cube times the height of the cube. That will give you volume. That's just the equation for volume of a cube. So 4 times 4 times 4. If you do that multiplication, 4 times 4 is so 4 times 4 is 16, and 16 times 4 is going to be 64. So 4 times 4 times 4 is 64. Okay. So if your mass is 16 and your volume is 64, that means your density is going to equal your mass, which again, 16, we just said that, divided by your volume. We just figured out it'd be 64, and this is centimeters cubed. So 16 divided by 64 and if you do that math, 16 divided by 64 is 0.25 grams per centimeter cubed. Okay. So again, finding density is pretty simple. All you have to do is figure out the mass, figure out the volume, and then do the division. So the mass divided by the volume, and that will give you your final density. Please don't forget to use units. This time was grams per centimeters cubed because we were given our measurement in centimeters. But remember, grams per centimeters cubed is the same thing as grams per milliliter. So if you put this in grams per milliliter, it wouldn't technically be wrong. So keep that in mind as well. So we got one more density calculation. We want to find the density of an object with a mass of 12 grams and a volume of 24 milliliters. So at this point, this should be pretty old hat. Density equals mass divided by volume. Our mass, in this case, is 12 grams, which is right there. Our volume is 24 milliliters, which is right here, 24 milliliters. Meaning that our final calculation will be D equals M, which is 12 grams, divided by V, which is 24 milliliters. 12 divided by 24 is 1/2, or 0.5. So 0.5 grams per milliliter. Get that a little bigger. 0.5 grams per milliliter. Okay. So I will provide you with that density equation, so I don't want you to spend all your time memorizing equations, although we don't really have that many this semester, so this one's pretty easy. Just know what M means, that's mass, know what V means, that's volume, and know what mass and volume are measured in. If you can keep those things straight, you should be in pretty good shape. So now we're going to start getting into chemistry stuff. So first thing we need to know for chemistry is making sure that if you see a title on the periodic table, so an atomic title, that just means that's on the periodic table. So when you see something on the periodic table, you should be able to kind of know what all the different things mean. So we're going to start right here. So we'll start right there. So oxygen there, that is the name, okay? All the elements have a name, okay? Each one has its own unique name, and the name is how we usually talk about these, you know, just in conversation. So if I'm going to talk to you about the element 8, I'm not going to say element 8. I'm probably not going to say O. I'm going to say oxygen, because that's just the name of it, obviously. Next, we have this number right here. This number is very, very important. It's called the atomic number. Okay. The atomic number is very, very important because that's what gives the element its identity. Okay, this is what tells you what element you're looking at. So every single element on the periodic table has a different number. That number, the atomic number, is what kind of lets you tell them apart. Next, we got this big letter. And so some of these are one big letter. Sometimes it's a big letter and a little letter. Anyway, that is called the atomic symbol. Okay, that's the symbol. So this is what's being used in chemical equations. This is used as an abbreviation often. So this is how you're going to see these things written out when people are actually doing, you know, scientific experiments, or they're doing some kind of balancing equations or writing chemical equations or anything like that, formulas. You're going to see the atomic symbol. Finally, the last thing down here at the bottom, that is the atomic mass. And you'll notice that it's a decimal, okay? They're all decimals because the atomic mass is actually the average mass of the element. So what that means is this is 15.999, which is really, really close to 16. So almost all oxygen atoms have a mass of 16. However, every once in a while, there's an oxygen atom that is a little less than that, got a little less mass. So it's not exactly 16, it's 15.9999, because when you average it out, most of them are are 16, but every once in a while there's one that's a little bit less than 16, which pulls the average down. But that's the atomic mass. It's basically telling you how much mass is in the average oxygen atom. So we got to go over the basics on how to find information about different elements using the periodic table. This information is very, very important. It's foundational to being able to do anything with chemistry. So if you want to have any shot at any of the other chemistry stuff, either in this class or in future classes, you need to understand how you find the number of protons, how you find the number of electrons, and how you find the number of neutrons. So this is not going to affect you just in this class, but this is going to affect you in classes going forward as well. Let's check our time. Excellent. So we'll start with number of protons. Number of protons is pretty easy to figure out for an element because number of protons, and remember the abbreviations, P plus, that's proton, N0 is neutron, and E minus is electron. Okay, so finding number of protons, so the number of protons equals the atomic number. So if I ask you how many protons are in a given atom, all you got to do is look up the atomic number. So for example, if I ask you how many protons are in an atom of lithium, all you'd have to do is take a look at your periodic table. And on your periodic table, you got to find lithium. And you'll find that lithium is element number 3. So if it's element number 3, it has 3 protons. Next, finding number of electrons. So to figure out the number of electrons, first of all, we usually assume that atoms are what we call neutral. Okay, so a neutral atom has no charge. If it has no charge, that means protons equal electrons. Okay, so if you usually, unless I say otherwise, you're going to assume that an atom is neutral, meaning it has no charge. If it has no charge, that means its number of positives equal its number of negatives. So if you want to know the number of electrons in a neutral helium, well, helium is element 2, so it's got 2 protons. But because I said it's neutral helium, that means that it's got 2 protons and 2 electrons, because protons and electrons equal each other. Please remember, electrons have a -1 charge, and these are located outside nucleus, and they are very small. Protons have a +1 charge, and they're located in the nucleus. And they have a mass of 1 AMU, which is just atomic mass unit. AMU. And finally, neutrons are neutral. They have 0 charge. No charge whatsoever, so they're not going to affect finding the charge or figuring out ions or anything like that, because neutrons are completely neutral. And they are located also in the nucleus. And they also have a mass of 1 AMU. Okay. That last part about mass is important. So here we said we have a mass on neutrons, and here we had a mass on protons. That matters because to find the number of neutrons, you're going to use the atomic mass. So the atomic mass equals number of protons plus the number of neutrons. So if you want to figure out number of neutrons by itself, that's just going to be neutrons equal the atomic mass minus the protons. Atomic mass minus protons. So an example of this would be oxygen. So oxygen, which is the one that we were looking at just a second ago. Oxygen has a mass of 16 AMUs, or atomic mass units. So it's got a mass of 16 AMUs. We also know it has 8 protons. So neutrons will equal that atomic mass, which is 16, minus the protons, which we just said was 8, and 16 minus 8, obviously, all together is 8. So that would mean that this oxygen with a mass of 16 has 8 protons and 8 neutrons. Okay, so we'll wrap here for today. Please do make sure that you are taking time outside of class to actually go over this stuff. It's really, really helpful to review it, practice it. It's amazing the amount of help it will do if you actually take the time to do that. You don't want the first time that you do a lot of this stuff to be in the test, because that will be a very unpleasant situation. So just try to make sure that you're practicing this stuff outside of class. If you're having any questions, please remember you can email me with any questions. Again, my email address is CELNIFFON for Olathe North at olatheschools.org. So if you're having any questions, you can go ahead and email me at that address, and I'll get back to you as fast as I can to answer any questions. Also, I'm going to have these videos, as you probably realized, are posted on YouTube. So if you need to go over this again, rewatch anything that you didn't understand, or just go home and show off to all your friends what a cool science teacher you have, feel free to look those up as well. So anyway, I will kind of see you tomorrow. My ghostly voice will at least talk to you tomorrow, and then I will actually see you with my own eyes on Monday, where you can ask me all the questions you want, and then we will take the test next week on whatever day your final is. So anyway, thanks a lot, and thank you for being awesome for the sub. I appreciate it, because I know that you are doing that. So anyway, have an excellent rest of your day, and I will talk to you, I guess, tomorrow.